Okay, now I'm solving another example of a complex quadratic equation. And here again, the value we want to find is the value of x, and the x is written here in exponent. So these are basically exponential equations, but these exponential equations can be solved using more than one method. If I try to solve this exponential equation uh, by using the same method of substitution and assumption, then the first thing I'm going to do is that I'm trying to get something with the same base. So in the second term, there is a base of 3 and 3 raised to x is written. So I would like to convert this 9 into a base of 3 also. So instead of writing a 9, I'm writing 3 square, and then there is an x in the exponent, and we have minus 28 times 3 raised to x plus 9 is equal to 0. Now in the next step, I'm rearranging the powers. So I'm writing the power of x on 3 and then the square on the bracket outside the bracket, and then we have minus 28 times 3 raised to x plus 9 is equal to 0. Now if we now go for substitution and assumption, then that would be easier. Y is equal to 3 raised to x. So the given form now becomes y in place of 3 raised to x. Everything else remains same. So wherever 3 raised to x was written, it was replaced by y. So it becomes 3y square minus 28y plus 9 is equal to 0, a simple quadratic equation. And now we can break the middle term with minus 27y minus y plus 9 is equal to 0. Taking 3y as common, y minus 9 minus 1 as common, y minus 9 is equal to 0. Y minus 9 again common, so 3y minus 1 equals to 0. So from the first factor, we get the value of y as 9, and from the second factor, we get the value of y as 1 upon 3. So both these values would be returned to the original form. We suppose that y is equal to 3 raised to x. So the first value of y is 9 and it is equal to 3 raised to x. Now for solving an exponential equation, it is necessary to either make the bases same or take log on both the sides so that we get the value of the variable. So here we can make both bases the same because 9 is 3 square, and when the bases are same and the terms are equal, their powers can be equated. So the power on the left hand side is equal to power on the right hand side, which means that x is going to be equal to 2, and this is the value of the variable. Now the same thing would be done for the second value, and it is 1 upon 3 is equal to 3 raised to x. If I move this 3 in the numerator, the sign of its power would change to a negative 1. So it was 3 raised to 1 in the denominator, and if I move it to the numerator, the sign of the power would change. So it means that 3 raised to x is equal to 3 raised to minus 1. Again, bases are same and the terms are equal. So it means that their powers must also be equal. So the other value of x we get from this form is minus 1. So this is how we got two values for x, minus 1 and 2. And this is the way to solve whenever uh, an equation in the exponential form is given. You go for substitution, and finally when you find out the value for the supposed variable, you return it to the original form and find out the value for the original variable by making either the basis same, or if the basis cannot be made the same, then we go for taking log on both sides.
We try to explain complex concepts in simple language and with effective examples. If you like the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel and press the bell icon. so that you stay updated and get notified when we upload more videos. Thanks for watching.